people can join in the next few minutes. So hello, everyone. Thank you for joining us today for our Solutions Engineering Hangout. And today it's going to be hosted by Kausar Kamal. So today we're going to talk about HashiCorp Consul. HashiCorp's Consul is a multi-cloud service networking platform to connect and secure services across any runtime platform in a public or private cloud. So a service mesh can help solve a range of security and speed to deployment needs, such as deploying services in a low trust network, rapidly iterating on service versions, migrating services, moving from monolithic to microservices model, and so on. So during this SE Hangout, Kausar will demonstrate how Consul Connect can help in these areas and more. So I also want to note that this SE Hangout is being recorded, and the recording will be made available to you guys. It will be on our website, and I will also email it out to all of you after post-processing, which usually takes 2 or 3 days. And so just on the agenda, the demo will be about 25 minutes, and then the remainder of the time we will spend on Q&A. So please submit your questions through the Q&A portal throughout the presentation and demo, and we'll get those answered at the end. So with that, let's go ahead and get started. You can take it away, Kausar.
Yep, awesome. Thank you, Brianna. And thanks everyone for joining us today and spending some time with us. We have an exciting demo today, and we'll try to make it, we'll try our best to make it worth your while. And at the least, there will be some cats, and everybody loves cats, so hopefully it will go well. My name is Kausar Kamal. I'm a staff solution engineer with HashiCorp, based out of New Jersey. I've been here for just over 2 years, supporting mostly the larger financials in New York Metro, and super excited to be here today. So just progressing, let me actually get into presentation mode. So in terms of the agenda, and as Brianna already mentioned, we'll do a demo. Before the demo, I have a few slides to go over, so that'll probably take about 10 minutes. The demo will be about 20 to 25 minutes, and then we'll have a Q&A as well. Now, in terms of what is the sort of business challenge that we're solving for, essentially, today we're going to see, as you deploy microservices at scale, you're going to start encountering challenges when rolling out new applications or new versions of existing applications or microservices. And especially when you want to do that in a non-disruptive way, because these days an application may be composed of tens or even hundreds of microservices when you get into complex applications. And if you're doing if you're managing routing between these services or managing security rules between the services based on IP addresses and port numbers, you're going to end up having just way too many rules to manage, right? Managing and validating these rules are going to end up adding a lot of time in your application delivery lifecycle. And that's really where Consul can help. So Consul can provide a uniform way to solve for the service to service, both the traffic management and the security challenge, right? And especially like when you start talking about a hybrid environment or multiple cloud regions, managing security rules and routing logic in that type of a scenario adds another layer of complexity. So we're not going to go into the multi-region scenario as much today. We're going to keep it just within a single data center or a Consul data center or a cloud region. But that is something that Consul can help with as well. So kind of moving forward, I just have a few slides and then we'll get into the demo fairly quickly. What's our story at HashiCorp, right? Our mission is really to enable customers to manage their applications and infrastructure across various private and public cloud platforms and also hybrid cloud environments, right? A lot of customers are going through that journey of moving on-prem applications to cloud or deploying greenfield applications to cloud. And while they're doing that, they're keeping the more transactional systems of records that are on-prem. So HashiCorp is really here to kind of help with that journey. When we look at our cloud operating model, we're not a platform as a service company, rather we're a sort of portfolio company. We have a collection of tools here on the right-hand side. We're actually very well known for our tools. So, a lot of you might be familiar with, some of these tools like Terraform and Vault. We look at the application delivery model around 4 critical problem statements, which are provision, secure, connect, and run. We think that if you can do all of these things well, you can ultimately reduce the time to value and differentiate yourself, right? So today we're going to focus on the connect layer, which is the service to service networking, which is really where Consul is coming in. Okay, so moving forward, so Consul is a tool, Brianna already kind of mentioned it a little bit at the beginning, but it's a tool that provides us a service registry. It provides dynamic health checking for applications and also service mesh capability. So I talked about that journey, going from sort of on-prem data centers to a more dynamic hybrid and multi-cloud environment. So when you go on that journey, you end up with mixed environments, right? Virtual machines, microservices, auto-scaling groups, containers, functions as a service, serverless like Lambda, etc. And what we don't have are sort of long-lived networks, long-lived sort of hosts with static IPs, right? So with this background, the core problem that Consul is really solving for is the service networking, which is naming a service, authorizing a service. So, when a web service is calling an upstream API or a database service, how do you authorize that service and how do we route among different services? So similar to Terraform, there's a huge open source community around Consul. The tool is written in Golang, so it's just a single binary that you can download and deploy anywhere. The demo today is going to be based on Kubernetes. However, the demo actually can be run anywhere. It could be on virtual machines or another orchestrator like Nomad. In fact, I was trying to have a sort of a multi-region story with a Consul cluster deployed on VMs and this Consul cluster deployed on Kubernetes and have federation among them. But it was just too much to cover in just a 1-hour webinar. So that's going to be considered future work. But Consul basically runs anywhere and it's very easy to deploy and operate. Right, so that's kind of what it says in terms of cloud. In this slide, you have the cloud agnostic icon here, so that's really what that is alluding to. So kind of digging into Consul a little bit more, we can talk about the adoption journey. Usually people start on the left, right? So Consul has a key value store upon which it builds a service catalog. So before I can kind of start kind of getting some value from Consul, we need a standard way of doing service discovery, an automated API-driven way to register services so that I can tell where healthy instances of my applications are running. So in this sense, Consul essentially becomes like the contacts app on my phone, right? So I can look up a person's name and figure out like all of the phone numbers and email addresses, etc. So similarly, right, Consul is going to be my sort of authoritative source for all of the instances of my services, and Consul will know which instances are healthy, are they running in an on-prem data center, are they running in a cloud region, right, and which region, etc. Right, so once I have all of my services registered and Consul is performing the health checks and kind of giving me the dynamic service registry, I can start to do some more interesting things, right, based on the service catalog. So for example, I can solve for the east-west routing. So whenever a service needs to call an upstream API service, a database service, etc., but I can solve for routing traffic to healthy instances. I can do blue-green deployments, right, based on service tag as an example. If I have a lot of sort of network appliances like software load balancer like Nginx, or even hardware load balancers like Big IP, etc., I could use Consul as a source for service discovery. So now I can sort of automate those network appliances, those firewall rules, etc. So there's no sort of ticket-based manual process to update them, and I can reduce my sort of time to deployment for an application. So really the service registry and discovery is the starting point for consuming Consul. So progressing with that network automation journey, the next stage is what we call service mesh, right? And Consul Consul Connect specifically is a set of features that, that support service mesh. So Consul Connect allows me to bring service identity-based authentication and authorization. It also brings a set of traffic management capabilities that we're going to look at today. Just to kind of drive that point home a little bit, right? Traditionally, an authentication for a service was done just based on its IP address. So usually I had a lot of sort of on-prem deployments in private subnets, and a service was considered trusted as long as it had an internal private IP, right? And that was kind of an arbitrary definition to begin with. You know, maybe we shouldn't have been trusting internal traffic, but that's kind of how we did things. So anything within a defined perimeter, once it passes my DMZ, was considered trusted. Anything outside of that perimeter was considered non-trusted. Now that we're getting into more complex architecture with hybrid deployments and cloud regions, we don't really own these networks, right? The Azure VNets, for example, or VPCs. These networks are inherently low trust. And the IP addresses are very dynamic, so we can't really use IP as a source of service identity. We need a different way to authenticate these services and then authorize these services, right? So we need to do that based on the identity of the service itself, and that's really where a service mesh can help. Those of you who are familiar with service mesh concepts, there's a control plane and a data plane. The control plane is where you sort of manage all of the authorization, and the data plane is where the actual data flows. So it's made of a set of sidecar proxies. So in this case, Consul Connect is the control plane, and all of the proxies that Consul is managing becomes the data plane. And so we're going to start getting into the demo now. The setup that we have is we have this application called HashiCorp. Pretend that we're a company called CatCorp, right? We provide kittens as a service. And our flagship application is this application that provides sort of software as a service version of cat images. And we're going to go through the typical journey. So we'll start with the monolithic version of the application, which is shown as version 1 here. Everything is deployed as just a single container. And then we're going to decompose that application into multiple front-end and back-end services. And going to a more microservices model that gives us the advantage of having different teams work on their individual parts in their own cadence. So we don't have to release the entire application at once. We can have smaller deployments of individual services, which is the journey we're taking, right? From version 1 going into version 2, and then eventually going into version 3, right? So, one of the things we're going to see as we kind of go through this journey is that we want to keep the end user experience, as non-disruptive as possible. So, as an end user, I shouldn't have to sort of change the URL that I'm pointing to get to the new service. And that also holds true for sort of your downstream services. So for example, for version 2, I have this web front end called HashiCorp Web. If I want to change the backend that it goes to, right? So if I want to go from this backend called HashiCorp Image to this newer backends called sort of URL and metadata, I shouldn't really need to redeploy the front end or do any kind of reconfiguration on my front end. I should be able to just route that traffic to the new version of my backend, right, that the service is consuming. And that's really where the traffic management can help us, do that in a very non-disruptive way. So to do that, we're going to be using some of these sort of logical concepts within Consul. These are called configuration entries. These are not all of the configuration entries, just some of the main ones that we're going to use today. If you go to this link, it'll provide all of them. The ingress gateway, this is new in Consul version 1.8. We've supported ingress gateways like Ambassador with Consul Connect, for example. With Consul version 1.8, the ingress gateway is becoming more native. So It's a kind of a configuration entry that allows you to configure listeners that can expose your application to the outside world. So we're going to deploy this application in Kubernetes, and it could be on VMs. And then that application is going to be within the service mesh, and then we'll have an ingress gateway at the edge that will allow sort of external traffic to come in and consume our application. The service router will define where to send layer 7 traffic in a very transparent way. So like I said, as an end user or as sort of a front end service, I shouldn't have to reconfigure, or I shouldn't have to redeploy myself with a new URL to know kind of which backend service to go to. The service splitter will define how to split incoming requests into different subsets of a single service. So I can define like a version 1, version 2 of my service, or I can sort of have an entirely different application and I can sort of split the traffic between them. We'll see an example of that today, like percentage-based splitting, as for example. Service resolver, what that does is, by default, this Consul will return, whenever you look up a service name in Consul via DNS or API, Consul will return the healthy instances for that service in a round-robin manner for the current data center and for the current namespace. But with using a service resolver, we can kind of modify that definition a little bit. So we can define which service instances map to a given service name. So we can now start doing very interesting things like define service subsets based on sort of metadata, tags, etc. Or we can target healthy instances of a service in a different data center, if you're getting into sort of multi-region scenarios. We're not going to get into that as much today, the multi-region scenario, but we will use a service resolver to define a version 2 of the metadata service. So we'll kind of look at that as part of the demo. All right, so what I will do now is everything is in this HashiCorp Docker repository, and there's also a Medium blog post that we'll send out where you can kind of follow all of the steps to run through the demo. I've already kind of pre-installed this application just to speed up the webinar a little bit. But if I do sort of kubectl get pods, you'll see that different version of the applications are deployed here. So all of the ones that start with HashiCorp are essentially the application pods. Let me do that again. So you have HashiCorp version 1, and then I have HashiCorp Web and HashiCorp Image, which is part of version 2, and then HashiCorp Metadata and HashiCorp URL, which is part of version 3. But to install the application, you just do make install, and then it will install the entire application. All right, so the first thing we need to do is essentially kind of do this. So we have version 1 deployed. We want to define an ingress gateway to allow people coming in from the internet to access this application. So the ingress gateway is already running, actually. So you can see here, there are 2 instances of the ingress gateway running, and it has listeners defined as well, but currently the ingress gateway is not pointing to anything. So what we're going to do is just run this command to essentially kind of define have an ingress gateway definition, which will allow routing to that HashiCorp application, right? And we have 2 listeners defined. We're going to use this first listener. This is a node port 32080. This maps to the ingress listener port 8080. So let's kind of go and hit this URL and make sure we can access this application. And there we go, right? So as I promised, there are going to be cute cat images. So hopefully, that'll resonate with you if you don't take away anything else. But this is version 1 of the app. This is just an Apache web server running in a Docker container, just very basic HTML, right? And what's really happening here is we have this, let me actually go to the Consul UI. So I'm looking at the Consul web interface right now. Under services, we have sort of HashiCorp. This is the version 1. And then we have ingress gateway that's defined, that's now allowing us to access this application out from the internet. Right, so now we want to kind of imagine a scenario where, you know, we have some competitors, right, that are trying to disrupt us. Oops, sorry about that. We have some competitors that are trying to disrupt us, and they have, you know, they have basically deployed a competing application, and we need to iterate on this application quickly. I apologize, my phone is ringing. Let me just turn that off. Sorry about that. Okay. So what we need to do is iterate on this application quickly and kind of come up with new version of this app that looks a little bit better, a little bit more polished. So to do that, we need to start decoupling the front end and the back end of the application. So we've hired some developers who are really good at sort of the web UI portion of it. And we want to get to version 2 of the application. So going to this diagram, right, we want to get to this scenario where we deploy version 2 of the application, which has a separate front end, right? And it has a separate back end component. So what happens is the front end can call the back end to get the URL for the image that's getting deployed, and also get some metadata about the image, like the caption for the image, for example. And going to this version of the application will allow us to kind of specialize, right? So you'll have a sort of team that works on the back end, a team that works on the front end, and allow us to innovate quickly on these features, right, independent of each other. So now that we already have deployed the app, as I mentioned before, I've deployed all of the application versions. What we need to do is configure the ingress gateway to point to this version 2 and do some canary testing, right? So we want to make sure that, you know, we have some kind of a test framework that's driving some load against version 2, and make sure that, you know, it appears, you know, just as we want it to be. So we'll go ahead and run another command, which is, let's see, canary, which will now configure the second listener on port 32. Actually, it's on port 8180, which is mapped to node port 32180. Just to kind of show what these definitions look like. This is the first one, ingress 1 that we applied. What it said is the listener port 8080 protocol is HTTP. It could be HTTPS, TCP, etc. Any kind of source, so regardless of which IP address you're coming from, route them to the HashiCorp service. The second definition we applied said, so there, as I mentioned, there are 2 listeners we deployed as part of the Consul deployment. For the second listener, route that traffic to HashiCorp web. And for the first listener, just route it to HashiCorp. So this is version 1, and then this is version 2 of the app. So now if we kind of go to this second endpoint, we should see a sort of a newer version of the same application. So let's go ahead and do that. Okay, so as you can see, this app looks a little bit better. You know, it's more centered. There's some color applied. You know, there's some fonts applied. The image is a little bit, you know, a little bit different sized, etc. And it's also more mobile friendly. So there's some JavaScript in this app. So if I kind of move the window around, it will resize the image automatically, as an example here. So it'll be a little bit more sort of mobile friendly. So this is version 2 of the app, and on this port, I can now do some canary testing, right? So I can drive some load against it and make sure everything is working properly. My live traffic is still going to version 1 of the application. So if I refresh this page, everyone's still kind of seeing this picture of the cat. If I go to the console UI, I look at ingress gateway, look at the upstreams. As you can see, it knows about these 2 upstreams, HashiCorp and HashiCorp web. So depending on which listener you're coming in, you're getting routed to either one of these 2 services. All right, so assuming that all the canary testing for this application is good, we want to route all traffic now in the main listener to this version of the application. What we'll do is kind of run the second command to apply apply a service router, right? So it has applied the HashiCorp router. We can take a look at that definition, right? And what this is saying is anything that's destined for the service HashiCorp now route that traffic to this new service called HashiCorp Web, right? So we've kind of modified the destination. So if I now refresh this page, I'm now seeing the new version of the application. So I've just kind of done just a sort of a fail, or I guess a blue-green failover to the green version of the application. So let's kind of continue with our journey. What we want to do now is kind of start decomposing this even more. So essentially, so now we're getting into this scenario where now all traffic is going into version 2 via the ingress gateway. And as I mentioned before, the web front end hits these two endpoints, /metadata and /URL for the back end, right? But we have deployed a new version of the back end written in Go, so it should be a little bit faster than Python. And it will return a sort of a modified URL. So this is version 3 of the application. And what we want to do is kind of canary test this backend service. And to do that, we want to have a rule that says if this special header is present in the traffic, then send traffic to this new version. Otherwise, if people are coming in without this special header, they'll see the kind of original backend, which is version 2. So we can again do that through a service router. So let's go ahead and kind of apply that definition. So that's this image router URL header. So if you kind of look at that as well, which is over here, this service router definition, what it says is any traffic that's destined for the HashiCorp image service, if it has the header HashiCorp canary equals true, and the path prefix is /URL, then route the traffic to this new HashiCorp URL service, which is part of version 3. Right, so to test this, what we can do is use curl. Let me clear my screen. So what I've done is kind of just sent a curl request to our first ingress gateway listener and grabbed for the image. And this is kind of the image that it's showing. This is what people are seeing if they if they just kind of go to this website via the web browser. But if I add a header, so if I added a header in curl called HashiCorp canary equals true, and I'm grabbing for that same image, let me actually change the port number. I can see that the URL is now changed, right? So this is giving me a different URL that's coming from version 3 of the application. So using this type of canary testing, right, header-based routing, I can test some of my backends without disrupting sort of the front end service, without disrupting the end user experience. So people who are viewing the website still sees the default image, but my testing framework that's coming in with this special header can make sure that this new backend that's deployed is working properly, right? So at some point, right, the canary testing will be done, and we want to kind of fail over to the new version or version 3 of this this URL service. So to do that, we're going to just run this command called, and this make command, these are all part of the make file, just to kind of show that real quick. In the repository, you'll see this make file here in the root of the repository. And these are just kind of targets, right? So when I do make for blue green, it's just coming here and kind of doing this command. So if you're doing this by yourself, feel free to come in and just run the commands directly. It's just more convenient to just write a single command and have kind of the console configurations or any other deployments apply. So let's kind of the blue-green deployment. So what that's doing now is, so remember, we were kind of at this point. We've kind of gone to this point now, where we want to now fail over all traffic. Any traffic that starts with /URL, we want to kind of now send it over to this new green service, right? So we want to do kind of a blue-green deployment where this is the green version of the service. So we send all of /URL to this new service written in Go. And we want to do the same for this, the /metadata, right? So before /metadata was going to HashiCat image, which was written in Python, but now both the URL and metadata should go to version 3 of the service. So when I did this blue-green deployment, I did not have to redeploy or reconfigure my front-end application, right? They did not have to know, they did not have to basically specify a new service name. They're still sending the request to the same HashiCat image service, but at the control plane, right, with using Consul Connect, what I'm saying is any traffic that's destined for HashiCat image, route them differently to these new versions of the service. So I'm trying to keep everything sort of, as minimal disruption or pretty much, kind of zero disruption to the end user or to the front end service. Right? And I can kind of visually see that within the console UI as well. So if I go to services, go to HashiCat image, I can go to routing. By default, the default route, and if I'm just coming in without any of these prefixes, it will just take me to the HashiCat image service. But if I am coming in and trying to access HashiCat image and the URL and the URI has the prefix /URL in it, it's going to route me to this new HashiCat URL service, which is sort of version 3 of the application. And if the URL prefix has /metadata, then it will route me to the HashiCat metadata service. So it's just kind of easier to see using the console UI as well. So now that I've kind of applied this routing definition, if I go back and kind of refresh this page, I'll see this in another really cute picture of this kitten. And it's a different version of the application. So it's a little smaller image, 600 by 400. The caption of the image has changed as well. What I'll notice is that the title still says HashiCat version 2. That's because the front end is still version 2, but the backends have changed. So the backend is providing the URL for the image and the caption for the image, right? So that's an example of how Consul can help us with sort of blue-green failover. The next thing we want to do is, again, we want to continue to innovate on this application and kind of decompose the services further. So we want to introduce a second version of this HashiCat metadata service. So this web front end, our front end developers have done a really good job and created this polished front end. They've also included the ability to rate images, right? So when you have a sort of an image show up, there should be a rating here just in terms of the number of stars this image is receiving from people. So this functionality is present in the web app, but currently it's hidden because the backend doesn't support it. So we want to deploy another version of the backend, right? HashiCat metadata where ratings are going to be enabled, so my front end can display that. So again, we're trying to innovate and deliver features as fast as possible, keeping the sort of the end user experience, right, pretty much as non-disruptive as possible. So to do that, let me now, and we want to do some traffic shifting between the two. So instead of doing sort of a blue-green hard failover to the new version from version 1 to version 2, we want to have everyone go to this first version and then gradually bring the traffic, like percentage-based routing, gradually bring the traffic to this version 2. Right? So, so that's called traffic shifting. And I'm going to kind of run this command. And that's applying a traffic resolver and a traffic splitter, right? So initially, we're going to start with 100% and 0% split. So what that means is initially 100% of the traffic is going to go to version 1, and no traffic is going to go to version 2. Right? So that allows me to be very conservative in the way I roll out a new version of the application. So if I kind of come back and refresh this page, nothing is changing. It's still kind of showing the version 1 of the application. If I now kind of go and apply a splitter, right, a 50-50 splitter. So I want to send 50% of the traffic to the first version, 50% to the next version. So I'll do this consul config write command. I'll come back here, and now what should happen is about half the request should go to version 1 and half the request should go to version 2. So I go back here, if I refresh the page, okay, looks like something has gone wrong with my new version of the app. Let me make sure it's actually deployed. 1 second. Whenever you're doing a live demo, you have to be prepared for something to go wrong. Let me make sure that the service is actually deployed. So yeah, I have metadata version 2 running. So it should be actually going to this. Let's see. Okay, so maybe it just took a little bit of time for the service to deploy and become healthy within Consul. So actually what happened is when I did make 5 shifting, it deployed that new version of the traffic, and it just took a little bit of time for it to get deployed and register healthy within Consul. So while that was happening, the front end couldn't reach the upstream traffic. So that is why it is very good to do some canary testing. So if I had sort of more of a header-based canary test, we would have caught this problem. But that's really kind of showing the value of traffic management, right? But now, now that the service is registered, and if I refresh the page, you'll see that about half the requests I do get the ratings, and about half the requests I do not get the ratings, right? So now I'm running both the version 1 and version 2 of these backend services. And at some point, right, I'm very happy with the ratings functionality, and I want to kind of send 100% of the traffic there. So I'm going to apply this splitter definition to send all of the traffic there. And now if I refresh the page, I should only see the ratings version, right? So I have an updated caption, welcome to Naya's app, and I have all of the ratings being displayed here. So that's really kind of our end state. We're coming in through the ingress gateway to HashiCorp web front end. We're no longer using the HashiCorp image backend, which was written in Python. Instead, we're directing the traffic based on the URL being requested to the new Golang service, HashiCorp URL, and we've gone from kind of 0% to 100% of the traffic to this new HashiCorp metadata service with ratings enabled. It's kind of one last thing on traffic management. If you want to see kind of what the splitter definition looks like. So we kind of have the splits defined here with weights. So these are percentage-based weights. We're saying that 100% of the traffic send it to version 1, and then 0% to version 2. We get to 50-50, that's just kind of 50-50 on either weight, and then eventually want to send 100% to version 2. These service subsets are defined using the service resolver. So using service resolver, I touched on this briefly earlier. Essentially, you can use metadata or the data center where the service is running. You can use that to define subsets. I know we're running a little bit low on time, so let me kind of wrap this up within the next few minutes. That really kind of ends the traffic management portion of it. We haven't really touched on security as much, but to kind of authorize the services to talk to each other, we need intentions. Right now, no intentions are defined. So I'm going to kind of run this one command to define all of the needed intentions. All right, so this is just use sort of command line. So all of the intentions are here. And what's going to happen is if I start deleting some of these intentions, then the application is going to stop working because I have sort of this default deny rule, right? Just to show that real quick, let me restart some of the apps just to make sure that any kind of existing connections are terminated. So it tries to get some new connections going and speed up the authorization failure. So I'll go ahead and delete these 2 intentions. While the service is getting redeployed, before we can do authorization, we also have to do authentication. So remember I said we're doing service identity-based authentication, not IP-based. So I have included some commands here that you can run, which will show you the root certificate and the leaf certificate. So this is the Consul Connect root certificate for this service mesh. For production deployment, we recommend not using the built-in Consul Connect CA, but using the Vault PKI integration. With Vault PKI, you can have a lot more flexibility. Like if you wanted to bring in your corporate CA, you can do that as well. Here we're just using the default sort of Consul Connect built-in certificate authority. And then using this command, you can also view the certificates that are distributed by Consul to each of the application proxies. So you'll see that this certificate, for example, is being given to HashiCorp Web. It starts with SPIFFE. SPIFFE is the framework that's generally used within service meshes to identify an application instance uniquely. So you have kind of the SPIFFE prefix and the SPIFFE domain. If you go to spiffe.io, it gives you a pretty good explanation. But essentially, the subject name for each of the certificates starts with SPIFFE. It has the Consul namespace, the Consul data center, and then the service name itself. Right, so I think the services have all been redeployed now, and then they are registering as healthy. So I try to go do this again. Yes, as you can see, it says upstream connect error. Let me zoom in a little bit. Or disconnect reset before header, reset reason connection termination. So what's happening here is the authorization entry from Ingress Gateway to HashiCorp Web is missing right now. So this request is trying to flow from Ingress Gateway to HashiCorp Web. There's an authorization check happening here that says, hey, there's no rule defined that allows the Ingress Gateway to actually call HashiCorp Web. So if we go and kind of remake those intentions, it should start working again, right? So I do this. You'll see some errors here because there are some intentions that already existed, but we created these two intentions right here. So Ingress Gateway to HashiCorp allow, Ingress Gateway to HashiCorp Web allow. So now if I kind of refresh this page, it should just kind of start working again. So there we go. All right, so, so let me wrap this up. So just in terms of what we have done, we've kind of walked through evolving an application, taking it from a monolithic version to, kind of iterating on this application, separating it out into microservices, deploying different versions of the applications and microservices, decomposing the front end and the back end into individual components, right? And doing all of that in a very non-disruptive way, and not really needing to redeploy the front end or the ingress gateway, doing all of that via traffic management. We didn't get to a lot of the other features such as fault injection, there are kind of multi-region sort of failover, things like that. No, we just didn't have time for that today, right? Some of the key benefits, right? Why would you even want to kind of do this using a service mesh? You can discover and locate instances with health status in real time. So Consul is able to kind of look at determine the status of all of these instances, make sure they are healthy. As you scale applications or deploy new versions, you can avoid downtime. All of these can be automated. Consul has a Terraform provider, so you can do all of this using the infrastructure as a code paradigm, right? So you can replace kind of error-prone manual processes. You can really take a lot of cycles that are generally part of the application delivery lifecycle, where you're just waiting for a ticket-driven process to get routing rules or firewall rules to get updated. All of that can be automated, right? You're kind of reducing the time to delivery. And then on the security side, right, all of this is protected by mutual TLS. We got to take a quick look at the certificates that are being used. And then we're kind of using authorizations rather than firewall rules. You can imagine if I have 5 instances of the web service, 10 instances of the backend service, that's 50 different, right? That's 5 times 10, 50 different sort of IP and port combinations for me to manage, which is replaced by just a single Consul intention, right? Allow ingress gateway to HashiCorp Web, or allow HashiCorp Web to write HashiCorp URL as an example. So let me finish here. I know we went a little bit over, so I'll hand it back over to Brianna for some Q&A.
Thanks, Kausar. Great demo. So we had a few questions come in, and just a reminder, if you do have any additional ones, to please put them in the Q&A portal and we'll get to them. So the first question is, can you discuss a little bit about how ACL and intentions work together?
Yep, absolutely. So that's a great question. When I deployed this Consul cluster, I did not actually enable ACLs for this cluster, but ACLs will kind of restrict what I can do on the control plane. So when I deployed this application, I had to register all of these services, and to perform these registrations, I had to have the permission to do that right within Consul. Because ACLs aren't enabled, so if I go to ACLs, you can see it's not enabled. I was able to just go in and register those services. But if I had ACLs enabled, to answer your questions, I would need permissions to define these intentions, right? So, no one can just go and delete these intentions. Like I just went in over the URL and just could edit and delete these intentions. I will need the permission to define all of these intentions, create them, update them, etc. There is a kind of a more detailed documentation of what are all the permissions that ACLs control, but they deal with registering services, deregistering services, registering health checks, right, things like that. So anything that I can do in Consul happens over the API, and all of those API interactions are limited by the ACL.
Okay, great. Okay, so where does Consul Connect fit into the Consul ecosystem? Is it a service mesh or is it part of Consul, meaning the Consul binary?
Right, okay. Consul Connect is part of Consul, so it's part of the Consul binary. In terms of the ecosystem, we do work with a lot of other technology providers like, F5 Big IP, Nginx, Nginx Plus. There's a bunch of others like Ambassador and a couple of others that I'm not remembering right now. I would say like those other technologies are part of the ecosystem that work with Consul. Consul Connect itself is just a feature of Consul, and that's part of the binary itself.
Great, thanks. Okay, so the next one. How does Consul route traffic if there are multiple instances of the same service running?
Right, so if there's multiple instances of the same service running, it's gonna round robin between them. So, in this example, I kept everything very simple and just had sort of a replica of one. I'll just show that really quickly. So for example, this is my deployment. You'll see the Kubernetes deployment is just a replica of one. But I could essentially make this 5 or 50, etc. And then Consul is going to find 5 or 50 healthy instances of that service. And then by default, it's going to round robin between all of those services, unless I start getting into the service resolver definition. So, right, when I deploy new instances of the services, if some of them have a different metadata tag, like I say that, hey, of those like 50 new instances of this same service, like 20 of them, I say service meta version equals 2 as an example. And it could be arbitrary, right? It could be any string. Then I can use a service resolver to make that a little bit more granular and direct sort of traffic routing. But to answer your question, by default, it's just going to be round robin between all of the healthy instances.
Okay, thanks. So this looks like the last one that came in. If anyone has any additional ones, please feel free to put them in. But what is the latency effect of routing traffic through proxies?
That's a really good question. It's been on my sort of to-do list forever to do a proper performance test with traffic routing enabled. I haven't gotten to that yet. Maybe it's helpful to kind of talk about, let me kind of bring up a diagram, right? So just architecturally, where this is happening, this is a diagram of a Consul deployment in Kubernetes. So Consul has, Consul has this notion of a Consul agent, which is a Consul binary that runs in server mode or client mode. right? So how this routing actually happens is within each node, I have this console agent that's on the left side of the diagram that's running in client mode. And whenever I define an intention or a traffic routing definition, like a service router, service resolver, this agent is configuring the Envoy sidecar proxy for that application instance. So I have this application pod where I have the application container, and then I have this Envoy proxy that's running. The Envoy proxy is talking to the local console agent using gRPC. So I don't have an exact number for you in terms of the latency effect. There is definitely going to be some latency effect, but it's going to be minimal because you don't. Whenever you apply a definition, that definition immediately gets pushed out to Envoy, right? Via Consul is built upon this gossip protocol where it can kind of very efficiently push out updates to console agents. So it's not like a polling mechanism it's not like so you don't have to like constantly go back to the console servers to check, hey, what is the latest, status of this service, service router, right? Whenever you make an update, it gets immediately pushed out, and the convergence time for console is really good. So it gets pushed out to the local Envoy sidecar proxy, and it'll stay cached there until that definition is updated again. So the Envoy proxy will have to do a little bit of additional processing to apply sort of that kind of service routing, but essentially, right, that kind of additional processing should be fairly minimal because all of that sort of cached within the local console agent and pushed out to the console proxy itself. Sorry, I know it's a long-winded answer, just to kind of wrap it up a little bit. I don't have the hard numbers, but since everything is cached within the local console agent, including the service discovery and the service names, there is no round trip back to the console server, so it should be a fairly optimized sort of process, and the latency impact should be minimal.
Okay, great. Thanks, Kausar. So thanks again for your demo and your expertise on all the questions. As I mentioned at the beginning, the SE Hangout was recorded, so I will email it out to all of you and it'll be made available on our website as well. And if you like what you heard today and want to explore more console, I encourage you to check out our Learn site, which is at learn.hashicorp.com. And here are a few other resources. He also has a blog post that goes along with this on our Medium platform, which the link is there, and we'll also include it in the email. And then we also host, if you're interested in learning more about console and you want to do some hands-on lab exercises, we host virtual console workshops. So feel free to go to events.hashicorp.com and you can register for a workshop. So I hope you all enjoyed today's hangout and have a better understanding of Consul Connect and Service Mesh. And a big thank you to Kausar for his time. Did you want to mention anything about the blog, Kausar?
No, I just wanted to kind of pull it up on Medium.
Okay.
Brianna's going to send it out, so you'll have
it. Yeah, perfect. Okay, so with that, we are all set. Thanks again for joining, and I hope you all have a great rest of your day.
Yep, thanks everyone for your time.